So with this video, I want to go over some ways to simplify radical expressions using the calculator and also by hand. I want to show you that in Moodle, if you go pull up Moodle, these three clips or videos will help you with this section in Units 7. So I want to go ahead and show you a few examples. So here I'm going to simplify this expression. The video to help you with the number in front, with the constants in front with this 48, the video that you need to click on is going to be this one here. And if you want to know by hand, it'll be this one here. So the simplifying radicals and simplifying using a calculator will help you with the 48. So I'm going to kind of briefly go over that, but if you want more in depth, just click on those two videos and it'll show you how to do that. So to get 48, I'm going to click on the calculator, hit my y equals, it'll be 48 divided by x squared. Then I'm going to hit second and then graph. And then I'm going to go down to where I see some zeros in front of the decimal. And then come up to and stop at the first pair of clean numbers that I see. Clean meaning they don't have any decimals. So the 4 and the 3 is the one I'm going to focus on. The 4 goes on the outside, 3 goes in the inside of the radical. So we know we're going to have, and since there's a 2 already on the outside, that 4 I'm going to put outside, I'm going to multiply together. So that negative 2 times a 4 gives us a negative 8. And then I'll have the square root of the 3 that was left in there. So this gets multiplied by 4. And again, that came from the 4 on the outside, and then the 3 gets put back into the radical. Now, to take care of the exponents, this is called a square root. We don't have an index here, but the index is going to be a 2 because this is called a square root. This is called a cube root, so this will actually be a 3 for the index. So, but if it's not written, it's understood to always be a 2 here. So what I'm going to do is you pretty much do long division with the exponents. How many times 2 goes into this 3? We're always dividing the exponents together. So off to the side, I say 2 goes into 3. It goes in at one time. 2 minus here gives 1. So whatever's on top, as far as I answer, will be what goes on the outside, and the remainder goes back in the inside. So I have 1a. So I'm going to have a, and then there's 1a left over. Same thing here, 2 goes into 4 2 times, but there's no remainder. So that means I'm going to have b squared, and there'll be nothing in the inside here because there's no remainder. And then c, 2 goes into 2 one time, so it's no remainder. So I'm going to put just my c out here, and then it's going to be nothing left inside. So this will be my final answer for this problem. Coming over to here, again, we're going to do the calculator technique to figure out what the root is for 375. So I'm going to do 375 and then divide it by x. And this time I'm going to raise it to the third power because I got the 3 from here as the index. So I hit second graph. Again, I'm going to go down to where I see some decimals in front of the zeros, 0 in front of this decimal, and come back up to the first pair of clean numbers that I see, and it's going to be 5 and 3 for this one. So this one here is going to be 5. I'm going to leave some space for my variables, and it's going to be 3 on the inside. So again, I divide. Always remember to divide. 3 divided by this index of 3, it gives me 1. So there's going to be a 1 variable here, nothing on the inside. However, 3 goes into 4. So we just do 3 goes into 4 one time. So we have 3, remainder of 1. So here I'm going to have a V and then a V left on the inside here. So this is going to be my final answer for this particular one. And always remember, don't forget to put your 3 back in there when you go to MyMathLabs Plus. Make sure you put the index back into the square root. Don't just leave it at square root because the MyMathLabs Plus will mark it wrong. All right, let's go over a few more examples. So if I want to, what this is called rationalizing the denominator. Basically, what we want to do here is when it says rationalize the denominator, basically I don't want any radicals in the denominator. So I don't want to see any radicals or square roots in the denominator of a fraction. If it said rationalize the numerator, that means I don't want any radicals in the numerator. So we have to figure out how to get rid of that. A simple background of this, if I have the square root of x and I'm times it by the square root of x also, this is actually going to be the square root of x squared. Our rules for multiplication of square roots, x times x gives x squared. However, remember this understood 2 here divided by this 2 gives me just x. So they pretty much just cancel out. Same thing if I have the square root of 5 times the square root of 5. That gives me the square root of 25, and the square root of 25 is just 5. So basically, when we have the exact same square root, they just pretty much cancel out. And just leaves you what's in the inside, which is just 5. So this cancels out with this one, leaving me with the inside here. Notice in my final answer, there are no square roots. So basically, that's what we're looking for is if we can multiply by the same thing, we can get rid of the square roots and all together. However, when we have a minus sign or an addition sign, we have to do what's called the conjugate. The conjugate is just doing the opposite of what is seen here. So we're going to multiply this whole thing by the conjugate. So times by the conjugate here, square root of 3 plus the square root of 7. See, I changed it. That's what conjugate means. You just change it from a plus to a minus or a minus to a plus. And what you do on the bottom, you must also do on the top. That's supposed to be a 7. So the bottom part is always the easy part because we can just actually put this in our calculator. So we can just make sure you put this in parentheses. And we can just put that in the calculator and it actually produces our bottom answer. So let's go ahead and do that. So parentheses, square root of 3, slide it over, minus the square root of 7 over. When you put over, when I say slide over, that means we want to conclude putting anything else in the square root. If you don't put that slide over, you continue putting things underneath the square root, which we don't want. Times the square root of 3 plus this time the square root of 7. And notice here it gives us the answer of 4, negative 4. So let's go ahead and put that underneath. And now for the top part, we're going to do what is called distribute property. So we do 7 times this square root of 3, which is going to be 7 square root of 3. And then we're going to do 7 times here. It's going to be plus the 7 square root of 7. Now notice I did not multiply this 7 times the 3 to make it 21. The rule is you have to have a square root in order to multiply the two square roots together. If it's just a regular number, it's understood to be a 1 in front. So we're doing 7 times this 1 gives us 7 times the square root of 3. Also, this is understood 1 to be here. So it's going to be 7 times the square root of 7, which is going to be the 7 here. And this will be our final answer. Let's do another example. Once again, we're going to rationalize the denominator, and we're going to do, again, what is called the conjugate. So again, we're going to write the same thing, but however, we're going to change this plus to a minus now. So square root of 5 minus the square root of 2, same thing on top. So once again, the bottom part's the easiest one. You can just put this whole thing in parentheses in the calculator. And I'm going to go ahead and just tell you what the answer is going to be. Once you put it in the calculator, it's just going to be 3. And just for the top part, we're going to do our distribute property. So maybe it'll help you if you put this in parentheses so you'll know you're multiplying the two numerators together. So we'll start off with the first one. 7 times this square root of 5 is going to be the square root of 35. So notice that they both have square roots. This has a square root, this has a square root, so I can multiply the insides together to get 35. Up here, I didn't have that opposite. This did not have a square root, so you have to do it just to the number in front, which is the understood 1. So now I'm going to do square root of 7 times the square the 2, the square root of 2. That's going to be a minus. Make sure you keep this minus with it. Square root of 14. So I am done with the square root of 7. Now let's do the square root of 5. So here, square root of 5 times the square root of 5. Remember that little trick. If it's the exact same square root, the square root just drops, and it's just going to be whatever is on the inside. So just plus 5. And then the square root of 5 times the square root of 2, that gives us minus 10. So we look here and see if we can combine any like terms. This is the square root of 35, this is the square root of 14, this is the square root of 10. If they were the exact same number, like 35, 35, 35, this is 35, 35, 30, then I can add them or subtract them together or combine like terms. Since they're all different, I can't do anything to this problem. This is a 35, that's a 14, it's a 10. There's nothing else you can do to the problem because they all have to be the exact same square root in order to add or subtract them. And what we're doing is we'll take the ones in front, and I'll kind of show you an example of that in just a minute. But this is our final answer. There's nothing you can simplify to this problem. You write it exactly like this in My Math Plus if you get to one like it. Let's do another example. So again, we're going to do the conjugate. We'll rationalize the denominator again. So this is the main one we're focusing on. Write the same radicals, but just change the minus to a plus sign. And also do it to the top part, or the numerator. All right, so the bottom part, again, you can just put this whole thing in parentheses, multiply them together, and put that in your calculator, and it will give you the answer to be 6. So we know the denominator is going to be 6 once I multiply this one and this one together. So we're just going to hold this off to the side right now. And you could do it for yourself. Just put this 3 square root of 2, all this in the calculator, and it should give you 6 for your answer. Now the top part is where we have to do some work by hand. So this is where we're going to take our do our FOIL. So the first one together, we're going to multiply that together. That's going to give us 15 the square root of 6 So notice here, I took the 5, multiplied by the 3, got 15. Square root of 3 times the square root of 2 got 6. So the numbers in front get multiplied together, inside the square roots get multiplied together. So next one, my pen keeps changing on me. So next one here, we're going to have the 5 times the 2 gives us 10, and it's going to be a plus sign. And then the square root of 3 times the square root of 3, remember that's going to be the square root of 9, which is the square root of 9 is just 3. So they remember the square roots just drop, leaving you with just in the inside. So this is going to be times just the 3, which this is going to give us 30. So we're done with the first one. Now let's do the second one. So we're going to do the negative times the negative square root of 3 times the square root of 2. Keep the negative with it. 3 times the square root of 2, that's going to give us minus 9. And then the square root of 2 is the square root of 4, which the square root of 4 is just 2. So this whole thing is actually going to be minus 18. And then we're going to take it to the last part, which is going to be minus 6, the square root of 6. Again, this is all over 6. Okay, so now it's time to collect like terms. Notice here, we have the same square root of 6 and the same square root of 6 here. And this is where we can combine like terms because both of the square roots are exactly the same. So we combine those together. That's going to give us 9, the square root of 6. Keep the same square root when we subtract it. We're just doing 15 minus a 6. 30 minus 18, that just gives us positive 12. All over 6. And to reduce, because we have a number in front here, so what am I reducing is the number in front of the square root, the 12, and the 6. Do not touch this 6 in the square root. We're just going to hear. So 3 goes in each one of these. 3 goes into 9 3 times, the square root of 6. And then plus 4 all over 2. And that's going to be our final answer for this problem. I have one more problem to go over. Example. Let's do 3, the square root of 3, minus 2, all over the square. My pen is acting up again. Let's try this again. So the square root of 3 minus 2 all over the square root of 55. All right, we want to rationalize the denominator again. So remember, how do we get rid of a square root? We got to multiply it by itself. That way the square roots would drop out and cancel out, leaving you with just on the bottom. So this cancels out with this square root, leaving you with just 55 on the bottom. And then we just do our distribute property. Square root of 55 and the square root of 3 gives us the square root of 165. And then the negative 2 times the square root of 55 is just negative 255. And that's going to be our final answer here. Now, the only last part I want to make sure we understand as far as simplifying, if I had a number in front, so if I had maybe a 4 here, so say that if I had a 4 here, square root of 7, plus let's do maybe 6, the square root of 10 all over 2. Because I have a number out in front here, out in front here, and out in front here, I can actually take this and reduce it. Same thing if I had maybe 2 plus 4, the square root of 10 over 2. Because I have a number out in front here and a number here and a number here, I can reduce. If there was no number in front of the square root, then please make sure you do not reduce these two together. It has to be a number here in order for you to reduce. So it has to be 3 parts, 1, 2, 3. You can't just reduce these two and then just say the answer is the square root of 10. So that's a no-no. So make sure you have 3 parts, one here, one here, one here.